see, am I on here? Thank you, Jennifer. My name's Jim Harris. I am a principal software engineer in Intel's data center group, and I'm going to kind of give a little bit of an overview of the state of the project, a lot of the changes that have gone in over the last year, what are some of the things that we're working on currently as a project, and some areas of focus moving forward. I'll have to say that I think it was about 5 years ago this month that Nate, who was up here on stage introducing Jennifer, Nate and I had this conversation, like, wouldn't it be cool if we could take some of the stuff that they've done with DPDK for network packet processing and do that for storage? And that was really kind of what started SPDK about 5 years ago. And I'd be lying if I said that thinking back then that we'd be at this point now, we'd have a couple hundred people in a room to talk about SPDK, like that would have sounded pretty crazy. So really thank you for being here. Okay, so current state of the project. So Jennifer talked a little bit about the community, and I think this is one of the biggest changes that we've had over the last year. If you look a year ago, SPDK was delivering a lot of really cool features, a lot of really cool technology, but there were some challenges from a community perspective for people who wanted to contribute who weren't at Intel. So the process for submitting patches, it was possible, but it wasn't easy. There wasn't a lot of transparency as the work that was going on within Intel as it was happening, as features were being discussed and developed and reviews were happening. That wasn't visible outside of Intel. And then finally, we had this really cool automated test framework that we run on every single patch. And again, this wasn't something that was really usable by the community. It was hard for the community to see the results of that. And so, a year ago, Ben Walker talked a little bit about this at our SPDK Summit, last year about some of the plans that we had. And it was really based around making this not just an Intel open source code repository, where Intel's just throwing code, out there for people to use, but to really make it an open source community. And so, kind of look at where we're at now. We're kind of this big, happy community, kumbaya, holding hands. Not really, but one of the big things is really increasing the web presence. So if you've been on the website, spdk.io, you'll see a lot of improvements, a lot of extensions, just really trying to get a lot better documentation, user guides, programmers guides, making it easier for people to kind of understand what SPDK is about, get it up and running, things like the Vagrant setup that Nate mentioned for the lab tomorrow, just making it easier for people to kind of get up and running. Email discussions. So we've had an email mailing list for a long time. What we've really tried to do is just get all the discussions out there on the mailing list. And I'll show a chart later that shows how much the mailing list traffic has really exploded over the last year. Weekly calls. So we have one call every week. And we switch between a Euro-friendly call, which was actually this morning. Paul tells me attendance was very light because everybody's here. And then we have on alternating weeks, we have one that's more friendly for Asia Pacific time zone. And then really supplementing that with these annual meetups. So we've had, some here. We've had some in Shanghai. We've also had a developer summit, a smaller session where we just deep dove into technical topics in Chandler last year. And I hope we have another one of those again later this year. I think one of the big changes was getting everything that's happening with SPDK out on Gerrit Hub. So Gerrit Hub is a public Gerrit hosting service that we use, and so every single patch that anybody's developing, Intel, outside of Intel, Hitachi, Oracle, all the companies that are contributing, it's all out there. And so everybody can participate in code reviews, everybody knows what's going on. And then the other key part of that is a continuous integration. So now all the full continuous integration environment that's been developed, all those results are publicly available. Currently, we're still primarily using a homegrown continuous integration environment, but that's being migrated to Jenkins, and we plan to do that switch over here within the next few months. So next is Trello. So Paul Luce, who you're going to hear from later today, he was a real big champion for this. He said, really, we need to get something out there for people to know how they can contribute, right? Somebody comes in and they're excited about SPDK and they want to contribute something. They want to get their feet wet. And so Paul really encourage this and help get this up and going. So we've got Trello, boards now for people who come in and they want to find something to do, and there's a list of things that they can go work on. And then we've got other boards for, a lot of the different features, improvements, feature additions, et cetera, just to kind of give people an idea of other things that are happening out there for people that want to jump in. And then finally, IRC. So having a forum that's more real time. So, most, the core maintainers, a lot of the developers that are involved in the SPDK project are on IRC. And so, if you need a quick question, this is really a great forum. In general, you're always going to find somebody on there, somebody that can help answer a question in real time if email's a little bit too high latency for you. Okay, so looking at growth. So community growth can be measured in a lot of different ways. I just picked a couple here. So this first one is SPDK GitHub traffic. So how many people are going to the SPDK project out on GitHub and looking at source code, downloading the source code, et cetera. And you can see this has increased quite a bit, pretty steadily over the last year or so. And then the mailing list traffic, so you can see especially over the last year or so, this has really exploded. I mean, it's if you kind of look at the numbers, it's almost tripled in terms of the number of messages. So I mean, there's really a lot of interesting conversations that are happening, a lot of debate, a lot of really good technical discussions on what's going on and how we're going to extend SPDK. And then of course there's the code, right? So community is great, and we need to have that community. I mean, at the end of the day, SPDK is a code base, and so we want to look at, from a technical perspective, how has the code base developed over the last year or so. So this is kind of showing some statistics for the last few SPDK releases. If we just kind of compare this most recent release from April and the 1703 release, which would have been March of last year, we can see the number of commits has almost doubled. I think the really key one here is looking at how many of these commits are coming from non-Intel contributors. So we've got companies who are really investing time and energy in SPDK, Hitachi, Oracle, NetApp, Fujitsu, a bunch of others that I'm probably leaving out. And so you can really see that this is really increasing a lot. And 9.1, that's not really good enough. I mean, we want to see this continue to increase. Okay, so now looking at the features. So Jennifer had the number up earlier, about 20 new features that have been added over the last year. And so this is a picture of the sort of the SPDK landscape, the building blocks that were available March of last year in the 1703 release. And then if we look here, we can see, there's been a huge amount of work. And not just here, but then, even some of the building blocks that were in here, there's been new features that have been added to them. I think we figured out during our prep for the summit that this format isn't going to work much longer because it's already getting to be an eye chart. We actually wanted to add vTune in here as one of the tools, but Intel Legal told me I couldn't just say vTune, I had to say Intel vTune Amplifier XE, and that wouldn't fit. So Ashish, if you're here, that's why vTune isn't here, but that's another tool that SPDK has done integration with over the last year. So we look at some of the major features, and again, you're going to hear a lot more about this in talks coming up. In fact, Felipe from Nutanix is going to be talking next about virtualization and how you can use SPDK to decrease overhead for virtualization, and a lot of that's done through VHost. So basically being able to present VirtIO, SCSI, VirtIO block storage into VMs, but instead of the hypervisor itself handling that, we can offload that to an SPDK process and do it much more efficiently with much lower latency. You're also going to hear from Chong Pong, who's here from our team. He's on our team in Shanghai, and he's going to be talking about how we've extended this to emulate NVMe devices in a VM as well. And he's going to talk a little bit about some of the advantage of doing that. And this also opens up other opportunities for containers. So if you're looking to build containers that are SPDK aware, VHost is a way that you can present that storage to other host processes as well. So we have drivers that can interact with this SPDK storage not just in a VM, but in another host process. Logical volumes. Again, you heard Jennifer talk a little bit about this earlier. This was really a key feature from the last year because it really sort of gave you an end-to-end, I guess, solution possibility within the SPDK building blocks. So, before this, you could take an NVMe SSD and present it over an iSCSI interface or NVMe over Fabrics interface, but typically you're not going to expose a whole SSD that way. That's just not how you're typically going to present your storage. And so this was taking some of the work that we had done with the BlobFS for enabling RocksDB and took the work we'd done with BlobStore, and it was developed from the beginning to be reusable, and now we can use that for logical volumes. So you can dynamically partition an SSD, and then most recently we've added support for thin provisioning, being able to do clones, live snapshots, et cetera, to just sort of build up the feature richness of SPDK. And next, user space TCPIP. So we talked a little bit earlier about iSCSI. We say SPDK, it's all user space, but hasn't always been 100% technically true, because for iSCSI, we still use the kernel TCP stack. And so, again, we're going to hear another talk from Ed Warnicki from Cisco and Tomek Zawadzki from Intel later today about FD.io, the fast data project, and vector packet processing in their TCP host stack. And so we've done integration work to be able to use that with SPDK as well. I'm not going to steal too much of their thunder. They're going to give you more details about that later. But this gives us another opportunity to fully move the entire storage I/O stack up into user space. Okay, so looking forward. So we have a few things that are in progress currently that I want to go through. One of the first ones here is orchestration. So we actually have a demo, which I think is available online. I think we have a link from spdk.io that shows a Cinder plugin. So this is work in progress. It's not pushed up to the Cinder project yet, but that work is ongoing. And it allows you to basically provision SPDK ephemeral storage with OpenStack. So to start, this is going to be using NVMe over Fabrics, logical volumes, being able to do dynamic configuration over JSON RPC. We see this as step one in a long road. So we're starting to talk about Kubernetes volume plugins, Nova extensions to be able to extend this to VHost. I think this is going to be an ongoing focus area for SPDK over the next couple of years. Accelerators. So there's hardware features on Intel CPUs like Quick Assist that enable accelerating things like crypto, compression, hashing, parity, as well as software libraries like ISA-L that can more optimize it in software with the instruction sets that are available on the CPU. And so DPDK has been providing this framework that is product neutral. It's a plug-in for whatever hardware is available on the system. And Paul Luce is doing some work here to basically be able to encrypt or decrypt block devices basically in isolation. So the common use case here that we see is being able to have a bunch of logical volumes being presented into VMs. Each logical volume is encrypted with its own key. So when the VM goes away, the key gets thrown away, and then that data is effectively not readable anymore. And so I think there's going to be a lot more work, not just on the crypto side, which will get upstreamed here within the next few months, but I think there's going to be other cases I'm going to talk about here in a bit. Open channel. So John Rudelik from Intel's Non-Volatile Memory Solutions Group, he and I are going to be giving a talk later to talk a little bit about open channel. And so John's going to give an overview of what open channel is. He's going to talk a little bit about Denali, some of the more recent work in the industry that's going on. And I'm going to follow that up with a little bit about what SPDK plans are for enabling open channel SSDs. And we really see this as an ideal environment, like using SPDK in user space. This is a completely new way of interacting with storage. It's It's kind of sort of block-based, but the traditional block APIs don't work anymore. And so we really see SPDK and its user space, pulled mode, asynchronous model, interacting directly with the hardware as a way to really optimize these kinds of applications. In configuration, so if anyone has, stood up one of the example applications in SPDK, the iSCSI target, a VHost target, et cetera, there's a couple of different ways that you can do it. One is you sort of handcraft a kind of an INI config file format before you start the application, or we provide some Python utilities to dynamically send commands to the running process to configure it. And that kind of sort of works, but we really want to work on how do we make this a lot easier. And so the first major, there a lot of work's already been ongoing on this, and I think we're almost there, is to have full JSON RPC configuration. So the idea is everything's based on JSON RPC. You can dynamically configure your system using it. You can dump all of the current configuration data to a JSON RPC file, and then you can replay it when you start the application again. So we don't have this sort of two different types of configuration. Everything's based around JSON RPC. And then also just providing a little bit more friendly terminal-based user interface, which we're calling SPDK CLI. So you can see a screenshot here of kind of what this looks like. So the idea here is you kind of have something that's a little bit nicer, menu-driven, directory-driven interface, helps a little bit easier to get, and you can more visually see how the system's currently configured and be able to interact with it dynamically. Okay, and future work. So these are all areas that people aren't actively working on today, but I think are going to be focus areas for SPDK over the next year or two. And my expectation is that some of these items we'll be talking about as completed features or in progress at our next summit. So first one is compression. When we look at accelerators, a lot of the accelerators that are out there today, like Intel Quick Assist, they support encryption and they also support compression, other features as well. I see potentially the ability to marry things like compression accelerators with like persistent memory. So using persistent memory to store, block bitmaps for, how you're mapping compressed blocks to uncompressed blocks. I think there's some really interesting work that could be done there. Database integration. So there's been some, we've done quite a bit of work with RocksDB, having a RocksDB plugin for SPDK, which then can be used when things like MySQL, and that's an ongoing effort. I think we want to, see some more focus here on getting SPDK to accelerate databases, kind of another application, not just storage networking or virtualization, but databases as well. Block device aggregation. So this one I lied a little bit because when I first put these slides together, this was future work and nobody was working on this yet. But actually, since I put these slides together, there's actually have been 2 sets of patches that have been pushed out for review for doing this type of aggregation, like striping, like RAID 0 type aggregation. And so, this is for cases where you have a number of SSDs on a system, you want to aggregate those into a single pool and create logical volumes out of them. So I think this is, definitely something that we're going to see integrated here in the next few months. And so sort of the corollary to that, mirroring and replication. So this could be RAID 1, local on a system. It could be dynamically configuring to store data locally and then remotely. This is going to require some additional, thought to exactly what are the use cases that SPDK wants to develop here. I think that's another really interesting area for future work. Fiber channel. So there are people that are doing stuff with SPDK and fiber channel today. A lot of it's not open source yet. I expect this to change over the next year or so, and I fully expect within the next year, next year's summit, that we'll have more details and more things we can talk about there. And then finally, deduplication. So this kind of is maybe in line with compression. So again, using accelerators to do hashing, maybe using persistent memory to store those dedupe tables in conjunction with SPDK storing the data on media. So So call to action, nothing really earth-shattering here. I hope you'll learn today, and I hope everybody's going to stay tomorrow too. There's a lot of really good technical talks tomorrow. We're going to have a couple hours in the afternoon to kind of have like a more of a developer, meetup type session, and join the community. So, we talked about patches. Patches are not the only way to contribute. Really, to be completely honest, like having people who are downloading SPDK and testing it, finding issues, like filing bug reports, like helping with testing, that's huge. Participating on the mailing list, like what are the use cases that you're interested in, those requirements. I think the community wants to make sure that SPDK is focusing time on what's important, and so that's another great way to contribute. Of course, we love patches and we love to get feature contributions, but there really are a lot of different ways to contribute. And finally, please, if you have time during the breaks or at lunch or this afternoon, if you have a chance, I'd love to hear more about how you're using SPDK, what your interest areas are. So if you have time, please introduce yourself. And so with that, I will take questions.
What kind of compression algorithms are you guys looking into?
I'm sorry, can you repeat the question?
What kind of compression algorithms, like for floating point data, or?
What kind of compression algorithms? So I think it's an open. I think it's something that we haven't spent a ton of time looking into. I think like block level compression is probably the big one, but I think certainly as we're evolving SPDK, I think we're going to be looking at more non-block type use cases as well. I think there's a question, yeah.
Hello. Just wondering, is there any plan to integrate like SPDK in distribution so that people will just get it and they don't have to do anything they don't have to build it or something like that, so that it's really easy to use in that sense, like integrate with distributions and
yeah. So like having SPDK packages available in a Linux distribution,
right? And also distributed by the Red Hat, SUSE, or Ubuntu
yeah.
and all that.
Yeah, no, that's a really good question. Yes, I think the short answer is yes. We want to move towards that. I think one of the things we're looking at is what makes sense. Is it libraries? Is it like the NVMe driver library, or is it more the full target application? And so, we are doing some work right now around packaging. Like, first, let's make sure we can package SPDK into something that could be distributed. But that's absolutely on the plans, and I think we want to move that way. Just to kind of give a little bit of a parallelization. So DPDK is now shipping with a number of distributions, and DPDK is kind of maybe 4 to 5 years ahead of where SPDK is yet. As some people will say, if John Meneghini's here, I'm sure he'll start. He'll have his own input here. But SPDK APIs are changing still sometimes, so we want to make sure we do the right thing. Like from a library perspective, we don't want to push libraries out that are the APIs are still kind of in flux. I think some of them are definitely becoming more standardized. The NVMe driver library the API's been very solid for probably almost a year now. I think that would make a lot of sense to have packaged, but that's the other thing we're kind of like weighing, like when's the right time to do that. And so I think what you'll probably see is first have a case where we would have packages for like the consolidated SPDK target that we have now, where like one SPDK application can do iSCSI, NVMe over Fabrics, and VHost. Maybe that's a package because that doesn't have a lot of the library dependencies. And then, as we move down the road, breaking that out so that you could have libraries for people who want to develop their own applications on top of it. We can't hear you, John. You're asking about versioned APIs? Yeah.
So ultimately, it would be good to have APIs that have different versions of your APIs, right? Having a single API that is just stuck there in perpetuity has disadvantages,
Yeah.
you know, on both sides.
Yep. Yeah. The API versioning, API stability. I mean, this is definitely another area that we need to do some work with SPDK. So, this is John Meneghini. For those that don't know, I knew he would have some input on that question.
We also have a talk on that tomorrow, right, Jim?
We do. Yes, that's a great point. Actually, Ben's going to actually talk a little bit more about this tomorrow.
Intel already support Vrock, creating the rate volumes on the NVMe. So are you planning to do something completely different with SPDK?
So the question is, do we plan to do something like Vrock with SPDK?
Yeah.
Yeah, so that's a good question. So some of the parts with Vrock, I mean, are related to you know, VMD being able to aggregate a bunch of, you know, devices and present them as a single volume. So I think the kinds of use cases that you would do with Vrock, I think can be supported with SPDK. I don't think it'll look the exact same. We have done some work with SPDK with VMD. In general, with most recent Linux kernels, it just works with IOMMU is disabled. There's still some things we're working through to get that to work on IOMMU enabled systems. But I think in general, the concept of being able to do like device aggregation with SPDK is something that we're definitely moving in that direction.
Hi, I'm Ahmed Siddiqui from Veritas Technologies. Just a quick question.
Yeah.
What are some of your near-term targets that we should watch out for in the next year for this community?
Watch out for as in like exciting things to be looking for?
Yeah, good things.
Good things, okay. So I think you know, definitely the crypto work, the acceleration work, I think that's going to be really exciting. I mean, it really kind of pulls in not just the software side, but the accelerator side as well. I think that's going to be step one in a number of different accelerator use cases. I think, you know, another big one is just the configuration side, so making it easier to use. I think it kind of goes along a little bit with the packaging question. Is like, how does the community make SPDK just easier to use? And part of its configuration, part of its orchestration, part of its packaging. And so I think certainly in the configuration side, it's going to make things a lot easier to use for people who are, you know, bringing this thing up and having a consolidated target that can support all these different protocols, just making it easy to be able to configure that. Man, I could probably go on and on. I think those are the two probably biggest ones. And then I think from a community perspective, I mean, I think the work we're doing with Jenkins, you know, one of the things we've wanted to do is to make this continuous integration environment not just something that can be done with inside of Intel, but other companies as well. So for example, like NetApp, they've been working a lot and giving us a lot of very good constructive feedback on ways that a lot of these tests are hard to run outside of our environment. So I think that's another thing that's going to improve a lot, is making it easier for other people to get these same tests running up in their labs, be able to, you know, test these patches before they even go out to the test pool, and then showing how you can even build, you know, a Jenkins instance around it to be able to manage those build artifacts.
Hi, this is Chetan from Western Digital. I'm relatively new to SPDK. What I would like to understand is, before any stable release, can you just touch upon what sort of testing does that go through? What are there any test beds that you test on before coming up with the stable release? What sort of testing does it really go through?
I'm sorry, can you
What sort of testing does the SPDK stack go through before coming out with the major releases?
Yeah, okay. Yeah, so kind of give a little bit of an overview on how the SPDK test process works. So we've got a number, at a top level, we've got, basic style checkers, compilation, et cetera, using static checkers like ASAN. We've got about, maybe 15 to 20 test systems, either bare metal or virtual machines that are running, a battery of tests against all the different components that are in SPDK. So combination of functionality like testing configuration, data integrity using FIO and its verification capabilities. And then there's a quite extensive unit test framework as well. And for anyone who's looking to get involved, unit tests are another great way to get integrated. And then we also have, we have the per patch test. We also have nightly tests that run, longer duration tests as well. And so that's really where the validation kind of falls with SPDK. I mean, we're always looking to find additional test cases and improve that. But yeah, it's basically a combination of the per patch tests across all these different systems, and then the nightly tests, which will run longer tests for maybe an hour to 2 hours at a time.
One minor note to add to that, Jim. I think one of the goals that the team's really been focused on has been trying to make every night actually be release quality, right?
Yeah.
So that's why there's a big focus on all those things that Jim talked about, right? We don't want to go for 3 months before we have something that people can use and trust. It's really, we want to get to a point where nightly it looks the same.
Okay, well this timer up here is flashing red at me. So if there's no other questions, yeah, thank you very much. Now, are we doing a break now, or are we moving to?
Let's do a quick 5-minute break,
Okay.
and then we'll move on and have Felipe get rolling.
Great. Hey,
Okay.
thank you.